Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about filament for 3D printing. So let's dive deep into it. Now first you have to understand 3D printing is started as with fused deposition modeling. Now let that be clear. I'm only talking about filament based system because there is powder based system, there is resin based system, and there are some more system, but we are only focusing on filament based system. Now this started with Strata system. They had patent on it. However, patent expired in 2015. So after that it became free for all. Let that be very clear. Whenever you have patent, copyright can last forever, trademark can last forever. Patents only last for 20 years, meaning somebody else can replicate it without any issue. However, they cannot call it the same thing. For example, that's why companies work their ass off to build brand loyalty. For example, Teflon is not the hardware, it's not the chemistry, it's just a brand name. So people should attach Teflon with that magical property. Now they hate it, but there was a time people used to love it. So that's why company will always do that. If they figure out something awesome, they will name it something else. So that name gets associated with that output. It's necessary. Now in 2005 these gentlemen came up with the idea of creating open source 3D printing. Now why is that? Well, here's the there is a cheat code in not in trademark, not in copyright. However, in terms of patents, you can just open it. It's like, oh, this is a, let's just say, a German company that has some patent on like how they are making their own electron microscope. If you can reverse engineer it, you can share it with the public. You just can't sell it. You cannot sell it. Then lawyers with missile will fire up you. So in 2005, RipRap project was started. And again, they started from base up, meaning not only how the heck you're going to make the electronics, how the heck you're going to make the frames, the geometry, all of that, kinematics, and the software needed to not only run the printer and software to actually slice the 3D models. So they did that, and they had a one philosophy. Philosophy was replicator, as in if you have one, you should be able to print the another one. Now, of course, that was a bit loose definition because as you can see, it was made out of mostly metal struts, threaded rod. That was the hype at that time. So they were like, you're gonna buy threaded rod. It was very common part from Home Depot and those sort of things. You buy it, you have one printer, you can print another one. And yes, they even designed the PCB to be one-sided, so you can use marker to mark it and then you can etch it. So they really went deep into it, and a lot of attention started to happen. But again, at this point in time, it is brutal. Like, you have to be command line wizard to deal with this sort of system. But the ball started to roll. A lot of universities, college people, and smart people started to dump their money into it. And over time, the patent expired 2015. So 3D printer starts to become a normal thing that people can be sold rather than building something from this. So that's happened, and then a big change happened. Creality Ender 3 hit the market. Now be mindful, before this there were many 3D printers. Ender 3 crossed the threshold, meaning it was actually cheaper than photo printers. Basically, 2D paper printer, it was cheaper than that. I bought it. And be mindful, it was not the greatest printer, but it was good enough. And it changed the world. Basically, the amount of unit they sold was bonkers. Like bonkers amount of units were sold. Like they were just like, so that's why Creality is big. Be mindful, Prusa is older company than that. Prusa has like good philosophy, good open source system, but they smoked their own cocaine. They actually they used the same philosophy of RipRap. It's like, okay, we're gonna make 3D printer and then we're gonna use the 3D printer to make more 3D printer. I'm like, that is the stupidest thing you can ever come up. And what did Chinese people do? Hey, 2020 rail that can be structure and linear bearing. Sheet metal, laser cut it, fold it, the end, go home. It's cheaper. This not only Prusa printers are expensive because it takes so much time, it also is like inferior. And you can see that Prusa's early printer was almost like RipRap kind of philosophy. But slowly over time, as they got bit slapped, more bit slapped, more bit slapped, they slowly started to add more and more metal into their printer. It's like, it sounds good. Oh, we're gonna 3D print it. Ender logic is like sheet metal, screw holes, the end, go home, done, sir. So Prusa happened. Now Prusa struggled a lot, and again, it was their own fault. Like, they smoked their own cocaine. It's almost like Elon Musk, Hyperloop, brain damage. So I do not blame Creality for doing that. Although Creality was a bad company, they were like, we're going to take open source, we're not going to open source our hardware. It's like people roasted their ass hard enough that they are like, okay, we're going to open it. So not greatest Chinese company, but hey. Bamboo Lab happened. Now Bamboo Lab was completely different. It's like, what if we close source everything? Like, people are going to roast your ass. It's like, yeah, but we're going to make it expensive. It's like, okay, why? Do not think about it. That's the whole point. Basically, they made Apple of the 3D printer, meaning buy it, forget about it. It will work. And they did pull it off. They freaking put a LiDAR into a print head just to make sure that a first layer adhesion is there. And let that be clear, if you're not familiar with 3D printing, first layer adhesion, good. First layer does not adhere, you're gonna waste plastic. So Bamboo Lab had that philosophy. Every other was like cost competing. Prusa had their own philosophy, but again, they lost Creality cheap created it. Bamboo was like, okay, we're gonna give you a very expensive printer, but it's like you buy it, you forget it. Like you just control P it, the end. Bamboo Lab becomes and in recent time, the one of the biggest anticipation was Snapmaker, because be mindful, nowadays you can't really give Ender 3 to people. It's like they will be frustrated. Like I had the original Ender 3, 8-bit board, noisy motors, noisy fans, and so much jiggering I have to do with that. So nowadays you want printer to be just a printer, just work. We are in 2020, just work. So Snapmaker comes up with something revolutionary. What if you have tool changer? Now let that be, Prusa does have tool changer, but it's like freaking $4,000. Like, yeah, good luck. It's actually more expensive than cars in India. So the Snapmaker comes up with a system that is surprisingly cheap, sub $1,000 for tool changer, for 4 tool head. That is shut up, take money. And be mindful, it's not just color. You might see people are changing color because again, it's obvious. But what you can do, go from single print head to like multi tool changer is like you can have different temperature and different material. You can literally design a box that has different plastics for different part, meaning you have one structure that is the structure, let's say ABS. Another, you can have TPU, that is the actual gasket for it. And all done in one system. And again, that's just one system. And you can use different color filament also. So you can have, let's say, some instruction or branding directly onto the plastic. It's like, it's a mind-boggling thing that Snapmaker worked their ass off and made Tool Changer a thing. So Tool Changer going now, as in like after 2026 and 2027, Tool Changer is the next battleground. Everything else is sorted. So world has changed now. What does that mean? That simply means when Ender 3 happened, people used to buy 3D printer and work on the 3D printer. Meaning I bought the 3D printer and I printed a lot of things that was just for the 3D printer. Then I was like, okay, now I'm gonna upgrade the board. Now I'm gonna add BL touch. Now I'm gonna add this. Some people added touch screen. I'm gonna do all this kajiggering. Now you buy the printer, you use the damn printer. So it's mature now, meaning you can, if you have money, either buy a Snapmaker U1 or Bamboo Labs, you can give it to most people and they should be able to just like print the end, it's just print it. So market is very mature now. So one thing you have to understand, okay, filament is the core of it. So construction method has its own signature. For example, if I'm asking you to make a square after like a square border out of wood, you will not use one big sheet and cut the center out, even if it's cheaper, simply because the grain will fight you. Meaning one side will become perfectly strong because grains are aligned. Other side will break like a Kit Kat because the grains are 90 degrees to it. So same way, like a wood has a signature. That's why your doors are never one big piece. They are always multiple small pieces aligned perfectly to the load. So same thing you have to do for 3D printing. 3D printing in 2 axis is actually better than wood because if you have a curvature to it, it can follow that strain path. So it's great in that regard. It's not just linear, it's actually adjustable in 2 dimension. Great, awesome. However, in Z dimension, basically X, Y, awesome. Z, no. For example, if I'm making this, this printing would be awesome, meaning I can put some load into this. This is like, I got this, fam. But here's it. If I print this part, yeah, if I bent it, it will break. Now this will not break because I know this. This strong, this not strong. How do you deal with that? I designed this to be 3D printed. So I have M3 bolts going through it. So compressing it. So basically I have a bolt going and then putting it compression. So this weak load, I have replaced it with freaking steel. So this is now strong enough. Basically now I'm using the best of both worlds. That's the same point. Why your wood requires structure. You can't just take a big piece and cut it however you want. You have to follow the grain structure. Same with 3D printing. In X and Y dimension, you can go YOLO. But in Z dimension, unless it's a load-bearing structure, you have to really think about it. Like, again, if you're making trinkets and just lightweight stuff, it does not matter that much. But if you're like, okay, you're going to put some load into it or you want it to last forever, yeah, you have to design it, because if you do not, most parts break from this axis only, because 3D printing is not isotropic. That's why I'm not talking about resin printing and powder printing, because if those two are done correctly, they should be very close to isotropic, very close, at least not this bad. So that's the whole point. The Z axis is very weak, meaning this GG, this not GG. Like if I twist it, it will fall apart. So layer addition is the limitation of the tech, and that's why 3D printer did not replace the world. People are like, okay, we're gonna print parts, and again, I used to believe that, but until you think about it, like really sit down and think about it, we have amazing polymer in this direction now, like really strong polymer, meaning you can actually compare that part to aluminum and steel and still come out on top. So we are strong, like we good. The moment you compare in Z axis, yeah, lol, meaning unless you have bolts or some sort of a clamping system, it's not really that good. That's why we are not using it everywhere. Even though in principle, like 3D printing, we matured it. We good, we got this. It's just that no chemist has figured out how to make a filament that auto magically seal up this part. Like this is the weak link, or a 3D printer that can do something to it. I've seen people like, okay, what if your layer was offset like a brick layer? But again, now there is a patent or on that. So let's see. That's the biggest limitation, and I have not seen anything that gives me hope or faith that fundamental problems can be solved. I think it would become better in future, but it will not solve. Meaning, if this becomes 10x better, this will be 1000x better by that time. So we'll always have that disproportionate requirement. So we don't have any actual solution as of now, 2026. Hopefully somebody can figure out magical system. Like, what if we have carbon fiber? Yeah, A, it's a health hazard for your lungs, and B, it does not actually give that much. There is a reason why whenever you are talking about carbon fiber structures, be it rocket, be it helicopters, be it supercars, they have full strands, one going this way, one going this way, one going 45, one going 22. Then they have the full stiffness. So you don't have an actual solution, but be mindful. If you go from cheap filaments to good filaments or industrial filament, you will have better adhesion. It's just that this adhesion, let's say it's a 10, it will become 50, but by that time this will become 5,000. So, but again, what if your requirement is only 30 and having 50 layer adhesion is more than good enough? Fine. But again, you have to design for it. Let that be very clear, design for it. Or the best thing you can do, compensate for it. Again, bolt, compensate, compression, GG. Don't worry about it. So that's the filament aspect of it. Now, the most common starting point filament is PLA, polylactic acid, so to say, and it's biodegradable. That's the good part. That's why everybody should start with that, because if I bury this in ground, it will disappear in few years. So that's the good part. Thermoplastic, great filament for printing. And again, let that be very clear. While you are saying polylactic acid, it does not mean it's just polylactic acid. There's a lot of stuff, special sauce, additives, suppressants, and basically polymer enhancers are added to it, including dyes. So A to B would be different. So PLA, the early days when we started, like 2015 to let's say 2019, I would say, PLA was not that great. Like the core chemistry was great, it was just blends were not sorted. But nowadays you do not have to worry about. Like nowadays we got this, we figured out how the slicer setting works, how the extruder works, how the temperature works, all those things are sorted. So nowadays, even if you are buying a very cheap printer, unless it's horrendously bad, you should be able to print PLA without any issue. And it can print in open frame, meaning it does not require a chamber. That's the biggest advantage it has. And blends have been perfected, meaning you good, like you have so much color option, and for cheap, like only 1,000 rupees in India. And I'm reasonably sure in America it's more cheaper than that. It's like $100 a spool. I'm pretty sure you guys be able to buy it for even cheaper than that. So it's very cheap, cost effective, lot of color option, very fine tuned. However, this puppy is weak in heat. I did not understand why like a lot of Westerners, when they are talking, oh, it's so strong, so stiff, and I'm like, all my testings are like, it's garbage. I'm like, oh, India is hot. Meaning this puppy only lasts strength wise to 60 degrees Celsius. Meaning if I throw it in my rooftop, it will melt. So yeah, heat wise this is not. So again, same spool, if I take it to Europe where they are like, oh, it's 26 degrees Celsius, it's hot. Yeah, those people are like, this is iron strong. Yeah. So heat wise it's not GG, and because it's biodegradable, really not good against ultraviolet. So if you put it in the sun, the heat will destroy it and ultraviolet will kaput it. And creep, meaning if I put some load on it constantly, it will slowly deform. Meaning if you are making hook from it, either A, you have to overbuild the hook, or be designed in such a way that you have something else supporting it. It will not last for very long duration. So if you're using hooks for something and it's only temporarily loaded, like let's say light for Christmas, light for Diwali, have fun. But if you're like, okay, I'm going to put this hook and I'm put lamps there forever, you have to overbuild it a lot. So the creep can survive it. So that's the issue. I do have PLA clamps on outdoor environment, hanging my tube light, still holding up. But again, I overbuilt it hell. And I'm pretty sure I have 4 of them. So these are the core weakness of it. Now we come to older material, which is ABS. And yes, that was ironically the first material. If you look into the rip-rap movement, the early days, everybody was using ABS. PLA was not sorted for this sort of application. So ABS was the first one, but it was very finicky. And that was another reason why people were not that deep into 3D printing in 2010. They were dealing with this sort of thing, meaning you print it, it cool down, crack. It requires chamber. And why didn't all the 3D printer manufacturers who are starting to sell in 2015, why they did not? The patent was expired in 2021, and I could see that, like 2021, before that, we can't do ABS. We can't do ABS. Everybody wanted ABS. The moment you add temperature, meaning in Indian environment, PLA is not desirable. ABS is. It's exponentially more stable at higher temperatures. So why don't we? We are waiting for patent to expire. Now everybody gives you heated build chamber. Have fun. So blends, again, ABS is a much bigger blend, meaning a variation between PLA of A to B is very little, but blends could be dramatically different in one vendor to another vendor. So ABS did require blends to be refined, so it was designed for 3D printing. And why do people deal with all the printer tuning, chamber and all that? Again, higher energy consumption also. It's simply because it's better for Indian environment. Outdoor temperature, I can trust it. Water resistance, I can, again, it's non-biodegradable, it can handle it. And flat out, UV resistance is a bit higher. Again, not perfectly high, but like I got this. And temperature wise, again, 100 degrees Celsius, meaning if I drop it on my rooftop, it will still be functional. So that's a big deal. That's a big deal, meaning if I'm making an outdoor part, I can trust ABS to last much longer than PLA. And again, before Europeans fire missile at me, be mindful, what is your local temperature? My rooftop temperature is 60 degrees Celsius on okay days. In very hot days, 70 degree. So yeah, even 100, I'm like, be mindful, 100 degree does not mean before 100 is like rock hard. It's just like 100 degree at certain load. If you have 2x the load, it will start to soften at, like, 99 degree or 95 degrees Celsius. So 100 simply means you should be much below that, or it does not have too much stress. So that is there fundamentally. But again, it's not something that I would urge you to start with. Even if you have an enclosed bamboo lab printer and all that, learn everything that you need to learn with a PLA, then go into ABS. And again, this is my first 3D printer enchantment, so to say. I wanted a 3D printer, now I have it. This is Ben Hack Show, ancient TV show. Back in the days, there used to be like a Revision 3, before YouTube became a big thing. He made the channel. The YouTube video after that Revision 3 shut down, that's 14 years old. I'm getting very old. So I watched that and I was like, such a cool concept. You have a 3D printer that you can fold in a briefcase, and the print quality was garbage. And I was like, why? Oh, ABS. Open frame ABS, yeah, no. Oh, and not to mention, that time, as in like 15, 16 years ago, slicer softwares were not that good. Retraction, those things were not that good. So it was very early on. And main board was 8-bit. Heck, even my Ender has been upgraded to 32-bit. So it's there. But again, ABS is a very good tool for elevated temperature. Now we come to advanced things. Now, advanced things is polymers that are specifically made for high temperature stability and chemical stability. And yes, I mean higher than what you have with ABS. So like for example, PTFE is Teflon. Again, that's why company always make sure they never tell you the chemistry name. They'll always give you some brand name, so you attach brand loyalty to it. Teflon. Nobody else can say their stuff is Teflon. That's why you cannot buy Teflon rolls. Even though it's all Teflon, you have to search for PTEF. It's a necessary requirement, so to say. So PEEK is also there, PEEK. If you have closing iron, some of the structures are PEEK. PBI and PES Again, there are a lot of them. And again, if you ever wondered what chemists do, they do that. Chemistry in polymer, and again, you will need PhD just to pronounce their name correctly. It's bonkersly long. And again, all of them are black magic material, meaning most of them are strong enough where they can be used instead of metal. And you're like, okay, why won't you use metal? While metal is strong, that's good, it is surprisingly vulnerable to chemicals, surprisingly vulnerable to things. And God help you if it's exposed to the water. So there are certain corrosive environment where you are better off with plastic. So in just after World War II, engineers needed to create a magic material that was strong as metal and robust as glass. And these sort of materials were created to solve that issue. But this is an industrial material. Normal you and I will not touch it, and the temperature needed for printing this is very hot. Again, if it's thermally stable at 200 degrees Celsius, your printer has to go above that. 420 degrees Celsius is required, 420 hot end temperature. So yeah, you can't use aluminum at that point, because if you have a block that has aluminum and you are pushing filament through, it will become elongated. Again, 420 while will not melt aluminum, it will soften it. So 420 degrees Celsius, you need different material, alloys, copper, or basically stainless steel. So you can handle the stress, physical stress at 420 degrees Celsius. And chamber also needs to be much hotter. So these chambers are like robustly built, almost like a furnace, mini furnace. So they could have temperature as high as 200 degrees Celsius. Not hot, basically that's the hot end temperature of mini PLA. This it would be the chamber temperature, and the basically hot end would be 420, meaning everything has to be redesigned. You cannot have electronics there. You may even require water cooling, and any and all plastic that is inside the structure has to be made from it. So these sort of printers are so expensive, they do not have a price. They have get quote. And again, the old saying applies. If you have to ask the price, you can't afford it. So it's there. It's again, leather figure. Normal people will never touch it. Hobbyists will not touch it. Because again, it's like $1,000 per kg of spool. It's brutal. And again, those are the cheaper ones. So it is very brutal. However, it has an independent market simply because aerospace, shut up, take money. For example, they're making a helicopter. They're like, okay, helicopter requires a door latch. Machining that door latch from aluminum was very heavy. They're like, okay, we're going to use that. They're like, oh, wouldn't that be weaker? Actually, no. And here's the deal. It has to be strong enough that it's not the point that fails. For example, you have this like, I want this to handle 1 ton. It's like, okay, what about these linkage? Okay, this is a freaking aluminum skin on aluminum frame that can barely handle 100 ton. You will design a latch that will only handle, let's say, 110 tons. Again, you do not want your item to fail, but there is no point of putting strength if your whole structure falls apart. It's like, okay, my train car can handle the joint in the train car can handle a lot of load, but the train car itself can't. What's the point? So it is becoming surprisingly well used in aerospace. And again, it can handle solvent, WD-40. It can tank those sort of corrosive environment. And chemical industry love this. And to give you how high these materials have reached, yeah, they are in ISS, International Space Station. And the future Artemis spacesuit, it will also have some parts that are made out of this. So yeah, it's high. But again, not for average person. And again, what about blends? Generally stay away from blends, specifically carbon fiber. Really bad for your lungs. You get only 1 batch of lungs. Thou shall not punch hole in lungs. And again, tiny strands, it does not give you enough oomph. And again, that's why when somebody has to make structure out of carbon fiber, it's like a whole hassle. You can't just powder carbon fiber and ta-da. That's not how it works. So this was my presentation on basically the mature era of 3D printing. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.